Okay, this is the ArcMAP tasks video, and we're going to do some very straightforward things here. We're going to be doing our distance work, and that's going to be, again, based on our cell towers. So we're going to be producing a distance, direction, and allocation raster, and then we'll be doing a little bit in terms of how we would look at those. And then we're going to be doing our density, and we're going to do a basic point density on automobile accidents in our study area. We're going to compare January to July and alcohol to non-alcohol. So let's get started. Okay, so here we are. We're in our ArcMAP environment, and what I've done is I've added from our week 3 data set our study area crashes, our cell towers, and then our study area boundary. Now I've added these two, which are background data sets that we'll be using next week a little bit more, but I do want you to at least see those as I move forward. So again, let's look at our study boundary. Okay, so we're going to click on that and then we'll zoom to it. Now what I've done here is I've made it hollow, and remember we can do that under our properties, and we're going to simply do a feature, and in terms of my symbology I'm going to have it be hollow, and I've made it red. Not any big deal there. Now in doing this, the first thing that we want to do is we want to look at our cell towers. So I'm going to click on that, and you'll notice that here are our cell towers within our study area. So now we're going to be doing a direction, distance, and allocation for that. So in ArcMAP, we're going to open our tools, and we're going to be in, let me make sure you see where I'm going, we're going to be to Spatial Analyst. And if these are disabled, remember that we make all of our extensions available in ArcMAP by clicking Customize and Extensions, and making sure that in this case Spatial Analyst is clicked on. Okay, so it's on, we're in good shape. We're going to go back to this, and the first thing I'm going to do is I'm going to use my Euclidean distance tool. I'm going to double click on it, and my input raster is going to be my cell towers. Okay, that's my first piece, and again I want to write this out to my results, and I'm going to simply call this cell distance. And here's where we get into a couple of these important ideas. We're not going to set a maximum distance. I'm not interested in that. We are going to create a directional raster. And again, we simply click on that. It's an optional thing. And again, I'm going to call this cell direction. And we save that. So those two are populated. But what I need to do now is, again, remember that we are in feet. I look down here and I say feet. And I need to have my cell size be appropriate. And so what I'm going to do with that is I'm going to use my environments. So I'm going to click on my environments. And there are two environments that I always want you to think about. First of all, the processing extent. That means, in a sense, where the analysis is going to occur. And so I'm always going to set that. And in this case, I'm going to typically use a polygon. And I'm going to say it's going to be the same as the layer that is the study boundary. The rest of that I don't have to worry about. And then I'm going to scroll on down to Raster Analysis. I'm going to click on that. And now here is an important idea. I could, and this is why I left these two here, each of these has very different raster pixel sizes. One of them is actually 3 foot by 3 foot. It's 1 meter pixel size. Very, very fine resolution. The other one, as we saw in the preliminary video, is 30 feet by 30 feet. And that's pretty small. And so in this case, but I really don't need it to be that size. But because I'm going to be putting some of these things together, I actually want it that way. So I'm going to say here that I'm going to ask it to be the same as elevation 1. You'll notice that it fills it into 30. The other thing I want to do is I want to make a mask. That means that I'm not going to calculate anything outside of this mask. And that's where I'm also going to put in my study boundary. And now once I've done those things, I'm going to say OK. And again, I've got everything filled out, and we're going to do planar distance, and I'm going to click OK. Okay, and so now we have our data sets. I've turned off the cell direction, by the way. And what I want to do now, though, because this is classified, I want to stretch it. So I'm going to go to Properties here. And again, I want to go to a stretched color scheme, and I'm going to change my ramp. And I think that I'd like it to show it getting much more red as it gets close instead of the black and white. And I'm going to apply that. Now you'll notice that it has standard deviations here. In this case, you'll notice that as I bring it into a stretched color, I begin to see my Thiessen polygons again. You can see actually the lines coming through here. And so a stretched versus a classified allows us to see those gradations a little bit better. In terms of my cell direction, turn that on. This is, and I'm going to open it up, this is classified. If I changed this, and again, classified makes sense here because it's within a range. If I clicked stretched here and went to some other type of stretched, what you'd notice is that you begin to have this kind of color range moving around. And it is kind of makes sense in that we have really 0 through 359 values as opposed to classified. But we can do it either way. Go back to our color scheme either way. But again, classified versus stretched. Now, the allocation surface, we're going to do a different one here, but I want it to work the same way. So I'm going to go back to my allocation. And in this case, what I'm going to put in as my raster is my cell towers. And we have no information here, so I'm going to give it the object ID. And again, we're going to output this to our results. Cell allocation. And in this case, again, we want to make sure that we get the right information. And so we're going to go into our environments. Now I want to point out something about the allocation tool. You'll notice that had I started with this one, this also outputs distance and also outputs direction. So if I'd gone into this first, I would have gotten all three of them out. But I wanted to show you the basic direction tool to begin with. So now I'm going to go into my environments. I'm going to leave these empty, by the way. But I want to do and kind of look at this in the same way. Remember, always start with your processing extent, and I'm going to set that as my study boundary. And then I'm going to go back into my raster analysis, and in this case, I really want to make sure that it matches my cell distance. You notice that it populates it to 30, and my analysis mask again to my study boundary. I'm going to click OK, and now we are going to say run. All right, now a very interesting idea here. If you look at this, you look at it and go, wow, that doesn't look at all like what I thought it would look like. In this case, again, we need to go into our properties, and you'll notice that it's stretched. Well, in this case, it can't be stretched, or it shouldn't be stretched, because this is, in fact, categories. And so what I'm going to actually do is I'm going to click on Unique Values, and it will now allocate these to the IDs that I gave it. And I'm going to hit Apply. And now you'll see that we have our allocation, or in a sense, our Thiessen polygons is a raster data set for each and every one of these. Okay, so that's it for our distance, allocation, and direction raster data sets. When we come back, we will be dealing with the density.